Okay, Assalamualaikum and good day to Doctor. So my name is Arif Amiruddin bin Sadiran, metric ID A19EC0022, and I am from PSDA Section 3, and I want to present on the report of our project 2. So let's go through to the index first, and we have few items here. So we have the introduction. Okay, I zoom in a bit so we could see much better. So the first is introduction, methodology, result and discussion, hypothesis testing, correlation, regression, and ANOVA. This is the type of statistic method that I use. So this is the conclusion, acknowledgement, and conclusion. So let's go through the abstract first. The abstract is basically the overall view of my project. So this study is to investigate the relationship of 6 different types of alcohol and its consumption among the teenagers in Germany who are between 12 to 16 years old by performing and finding inferential statistics such as hypothesis testing, correlation, and regression model. So this is the method that I use, and let's go a bit on the introduction of alcohol. So what is alcohol actually? Alcohol is basically an ingredient, a chemical ingredient that is found in alcoholic beverage, and the chemical ingredient is called ethanol. And alcohol is formed when sugar is break down during the process of fermentation and without the presence of oxygen. So as we know that sugar come in different type of fruit and different type of fruits. So let's say from grapes you could actually make wine, barley you can actually make beer. So different type of fruit and foods actually produce different types of alcohol, and alcohol can be pros and cons. So the pros is actually acts as a stimulant to inducing a feeling of euphoria, basically a feeling of happiness and talkativeness. So when you drink, you actually talk to stranger or person that you know actually much let's say much closer. However, in a large dose, it actually can lead to drowsiness, respiratory depression, so coma or even death. So in the long term, it's really bad for your health, and I don't recommend drinking. And this study is aimed to investigate the different types of alcohol with each consumption among teenagers in Germany with age between 12 to 16 years old. So between 12 to 16 years old, teenagers, 12 to 26 years old teenagers in Germany. And the data set, this is the methodology, so we explain what and where the data actually come from. So the data is collected by Social Science Research Institute in German. So the name of the institute is Institute für Jugendforschung, GmbH, für Sozialforschung, and Statistische Analyse MBH. I'm not sure if I pronounced that right. And the name of the institute is in German, and the data is actually collected in German Ministry of Health Education. And I obtained this data through a website, a database website, which is called Kaggle, and I provide the link here. And the data are selected from the data set. The data will then be sampled for hypothesis testing, and we use RStudio and R language to write the codes and basically calculate everything that we need to in our project. So let's go to the first statistic method, which is called hypothesis testing. So this is called a bell curve, and let's just go through the process from the first to the last. So from alcohol consumption statistic conducted by Eurostat, the consumption of alcohol for once a month in Germany is 21%. Hence, the null hypothesis or HO, alternative hypothesis H1, we use the 21%, so it is over 100, so 0.21. So we want to test whether the claims that is posted by Eurostat is actually true or not. So this is the mean. The mean of the data collected. This one, our data is 0.294. The standard deviation can be calculated using this formula, and this is the usual formula for standard deviation, and this is the answer for standard deviation, 0.10534242. And at 95% level of confidence is used to test the claim of this study, which is that 21%. And so since it is 95%, so it is 0.05 confident interval, and the critical value for 0.05 is 1.645, and the test statistic of mean. So this is the test statistic formula. So we use this formula, and this is basically all the answer for all the calculation needed for hypothesis testing. So the mean is 0.2940667, and it is the same, but this one is in 3 decimal, while this one is in all the decimal basically. And this is the HO, the one that is provided by Eurostat, standard deviation that we calculate, and the test statistic, and this is the critical values. And we can see here that the test statistic is actually less than critical value, so we can say that we fail to reject the null hypothesis HO. So what does this mean? So it basically shows that the stats, the 0.21 is actually still true, even though it is different, but it is minimum difference. So we reject the HO and we claim that the Eurostat is still true. And for correlation, while this one, while the hypothesis testing, we want to check whether a specific or any value from a global index is actually true or not. So we basically validate the value. For while correlation, we want to see the relationship between the variable X and variable Y. So in this case, ages and the beer consumption. And so we want to see whether certain ages actually prefer to drink more, or youngest people actually love to drink more. So that's what we want to see, the relationship. And so this is the value representation. This one is for X variable. So 1 represent the age range from 12 to 16, 2 to 16 to 18, 3 18 to 22, 4 22 to 26. So in this correlation test, we are going to find the coefficient correlation R. So R represent the strength of our relationship. So if it is positive and between 0.8 to 1, it is considered a strong relationship, while between 0.7 and below, we can say that moderately, and 0.2 below, which is equal to weak. And of course we also have negative correlation. So for negative correlation, the variable X and Y goes the opposite way. So if X is larger, maybe the Y will be smaller. So it is that difference. And what we found is that correlation coefficient is equal to 0.7234307. So you can say that this relationship is moderately strong. So, and it is also a positive reaction. So we say that when you are older, you actually love to drink more, but it does not for everyone, as it is moderately, which is 0.7. It's not equal to 1. So we cannot say all people who are older actually love to drink. So that's why it is 0.7. And this is let's say the conclusion. So thus, as the age increase, the beer consumption for at least once a month will also increase. At 0.05 variable, significant is used to test the linear relationship between the two variables HO. It's assumed the beer consumption at least for once a month has no linear correlation relationship. So the HO, so the HO is, we can say that it is equal to 0, while the H1 is not equal to 0. So we will calculate the test statistic to validate the claim of HO, whether it is true or not. So the sample size is 22. This is the same answer from before, 0.7. The test statistic according to this formula, and it's calculated in RStudio. And this is basically the overall calculation that we use. So we have test statistic T. This is the confidence intervals and degree of freedom, critical value. So we have the bell curve here. And since the statistic is larger than critical value, so 30 is actually larger than 0.36. So at interval 0.05, HO is rejected. So we reject that C has no linear correlation, because here is equal to 0, while our correlation is actually 0.72. So we reject that. So we say that 0.7 is the correct one. And there is sufficient evidence to conclude that there is a linear relationship between beer consumption for at least once a month, again age years. And that is for correlation. And then we go to linear regression. So what is the difference between correlation and linear? So we basically use the same scatter plot, while for this one we have a straight line. So we have a y-mx equation with the, just basically we have a new equation for the straight line, and this is what the variable x actually represents. So 1 is the range of ages, and this is the scatter plot. And so linear regression is a method of predicting model. So when we do linear regression, we have an equation of y for the straight line. So we could predict the intercept for every variable of x. So let's just go through. So this is the basic, the general equation. So our claim, the null hypothesis is that B1 is equal to 0 and B1 is not equal to 0. For this one is for H1. And the regression show the relationship between the beer consumption for at least once a month, again age, and the dependent variable is beer consumption, and independent is actually the ages. So this is the equation that we obtain. So y equal to 18.239 plus 11.123x. So whenever we want to test a value, so we just put the variable of x and we got the result of y. So this BO, which is equal to the estimate value of y when the value of x is equal to 0. So basically we say that when the x is 0, the value of y will absolutely be 18.239. And yeah, and that's it for the explanation. And this is the formula of regression confidence of determinant, coefficient of determinant. So it is equal to R2, and the coefficient that we get is actually 0.52303386. Thus it could be considered a weaker linear relationship between the consumption, but not all of the variables is explained by the variation in x. So we could predict using this equation, but it's not as accurate as what we will see when we actually conduct the experiment. And this is the calculation for everything that we use in this statistic method. So we have the test statistic, the confidence interval, coefficient of determinant, and critical value. So this is the bell curve, and what we see is that 4.3, the test statistics actually larger than critical value. So we reject the HO, and so we can conclude that there is sufficient evidence to conclude that the H actually affect the beer consumption for at least once a month. and we go to the last test. So the last test is actually ANOVA. So it is method to compare different type of alcohol. So we list 1, 2, 3, 4, 5, 6. We have 6 types of alcohol here, and each of its consumption, and we use significant level of 0.05 to test the HO and H1. So the HO is that the mean of consumption for 6 different type of alcohol is actually the same, it's equal. And for H1 is at least one of the consumption for 6 different types of alcohol is different. So the result shown as below. And this is basically the data, but in a table form, so we could see it much easier, because when we take a look at the Excel file, it's just full of numbers, so it's hard to see the data. Well, in this one we could see that the beer 43, 43.3, 47.3, and basically all the data that is available for ANOVA test. And this is the table for the calculated data. So we have type of alcohol, the mean for beer, the standard deviation, variance between example between sample, variance within sample, F, this is the test statistic, critical value, degree of freedom, and this one is for numerator, and degree of freedom for denominator. And then based on the value that is calculated, we found that the test statistic 3.78048 is actually larger than critical value, which is 2.621. Thus we reject the HO. So we can conclude that each main consumption of alcohol is different. So it is logical answer, because different people prefer different type of alcohol, you could say. And then we go to the conclusion. So conclusion of our test, of our project. So we go through one by one. So based on the test statistic, we failed to reject the non-HO, as there is sufficient evidence to support that the claim of alcohol for once a month in Germany is 0.21. So we can conclude that the percentage of 0.21 is true. And that one is the statistic from Eurostat. We reject the HO. Next, we reject the HO, which show that we have sufficient evidence to conclude that is a linear relationship between the beer consumption for at least once a month against each. And next, we refer to the correlation. So let's say next, in correlation, we reject the HO. Okay, so there is a relationship between the two, and the estimate regression model is able to calculate this is the equation, and this equation is used to predict the beer consumption for different ages. And while in ANOVA we have concluded that all the mean for different type of alcohol is different, and that is all for the conclusion. So sincere appreciation is extended to our lecturer, Dr. Arati binti Bakri, for helping on this study. And even though we are studying online basically, so we don't really go to physical class, and I appreciate that our lecturer, Dr. Arati, is actually consider us still teaching us, and always give notification on WhatsApp whenever a new announcement is created. So instead we still came in charge with the lecturer with the student. So I really appreciate it, and thank you, Doctor, for teaching us for this time. And this is just the list of our reference, and thank you, Doctor.